Alright, so far this week I've been going through Chapter 7 in Fire in California's Ecosystems, and this is all about the interactions that wildfire has with soil, water, and air. And so far I've just been going through the soil part of this chapter. First it goes into the physical properties, and then what I was reading today was talking about the chemical properties of soil. So just a quick refresher on some of the physical properties. We talked about how wildfire interacts with soil temperature. Obviously, if you have a fire coming through, that's going to generate some heat, and some of that heat can go into your soils. Now, most of your heat is going to be going up, heat rises, but about 8 to 10% of the heat from your fire will go down into your soil. And that can be a bad thing because it can kill some of your roots, maybe your seed bank, maybe your fungi or microorganisms that are in the soil. And then that can have some negative effects. But the good news there is that it's actually not the fast, high-intensity fires that have the largest impact on soil temperature. It's actually the slow-moving, less intense fires that can make your soils heat up more. I think it's just because they spend more time moving over your soil, so there's more time for that heat to conduct down. Now, one thing that works well in soil's favor is there's a lot of air bubbles in the soil. It's not just completely compact most of the time, at least if you have a more coarse soil as opposed to clays, which would be a lot of very fine particles. So that is going to reduce the amount of conduction that you can have. And then in your soils, you also have moisture. So before your soils can heat up too much, a lot of the moisture is going to have to evaporate out of them. So that's, I would say, pretty interesting. I did come across something else that talks about soil temperature and soil moisture. Today it was actually in the chemical section of this chapter, but I feel like it almost goes well with the physical properties that I was reading about yesterday, where it talks about how if a fire comes through and clears out a bunch of trees, you have a reduced canopy, which means you have less shading for your soils, which makes sense. They're going to get hotter because they'd be picking up a lot more sunlight throughout the day. And then on top of that, if you have more direct sunlight coming in and your soils are hotter, then you're most likely going to have more evaporation out of your soils. So that's going to make your soils drier. And then where do plants get their moisture from? It's from the soil. So then you're going to have drier plants, and then that would make wildfire more likely in the future. So I always like learning about the positive feedback loops in wildfire, where a fire comes through, clears out the canopy, makes your soils hotter and drier, which makes your plants drier, which makes it more likely that another fire comes through, clears out even more of the canopy, makes your soils even warmer and drier. Although I'd say I like the negative feedback loops more because that usually doesn't lead to a snowball effect rolling in the wrong direction. Although it depends on kind of your perspective there. Now, one other thing that maybe balances it out if we do want a negative feedback loop, so one that doesn't turn into that snowball effect, is if a fire clears out the canopy, now when a rain comes in, that rain's going to be able to go directly to the soil. It's not going to be caught by the trees. You can think of the trees and the bushes as almost interfering with that water going straight down to the ground. So in that aspect, you might actually get more moisture down into the soils, which then could bring some more moisture into your plants and then reduce future wildfire activity. But I'd also imagine that if the rain is stopping within your trees and your bushes, that those plants have a way to absorb those water droplets. So yeah, that's something else that's somewhat interesting. Another one in terms of the soil properties is whether fire makes your soils more coarse or finer. So in one aspect, it says it can make your soils more coarse. So think larger soil grains, I don't know if that's the right word there, versus very small soil particles. And that would happen if the fire is hot enough to actually fuse some of your clay particles together and form larger aggregates. But it seemed like most of the chapter was talking about the opposite happening, where a fire comes through, maybe your soil temperature gets too hot, and it takes out a lot of the maybe organic matter or your fungi or whatever it is, maybe it's bacteria that aggregates the soil together. So then you actually end up with less aggregated soil. So it's finer particles. And then the reason that's important is because if you have a bunch of fine particles, there's not as much air between your soils. So in one aspect, you'd think it would be able to heat up more if another fire comes through. But maybe more importantly, if you have lots of compact, very fine particles in your soil, it's going to be harder for water to infiltrate into the soil. And then it also makes it more likely that you'll have things like erosion or maybe flooding if there's less infiltration capacity. Maybe it would be easier for runoff to occur. But then the erosion aspect, you think it's easier for water to pick up those very fine soil particles as opposed to the aggregated ones. So storm comes through, be able to clear out a lot of your soil surface. The other interesting physical property one, I'm still just doing the refresher of yesterday's video, is if you have a fire and you get a lot of charcoal on the ground, that's going to make the ground a darker color, which means it's going to be able to absorb more heat from the sun. Just like if you're wearing a black shirt while playing. Today I was wearing a dark green shirt while playing pickleball, and I regretted it immediately because it was much, much hotter than the white shirt that I was wearing yesterday. So I was getting a lot more tired on the courts than I needed to. But still stayed out there for about 4 hours, so had some good fun pickleball today. So fires make your soil darker. If you have charcoal incorporated, that's going to increase your soil temperature, which could increase your soil or decrease your soil moisture because you get more evaporation, and then that could lead to more wildfire in the future. Now, the one other interesting one that I never really thought about that I learned about yesterday is talking about water repellency. So if you look at a leaf on a rainy day, sometimes you can see the droplets just staying on the leaf because some of those leaves have almost like a water repellent. Think of it as like a wax or a resin. And if a fire comes through, some of that wax or resin that's water repellent is going to almost melt down into your soils, and then it can cover your soil particles, making your soil almost water repellent. So then let's say you have a very prolonged dry period where you end up having all of that water repellent soil just kind of hardening. Then if another storm comes through, instead of that water being able to infiltrate down into your soils, it can actually just lead to more flooding or erosion. So I thought that was interesting as well. So that wraps up some of the physical properties of soil. Today I was learning about the more chemical properties of soil, and maybe I purposely talked a decent amount of this video about the physical properties because I think I understand those a bit better. It's a bit more intuitive to me than some of the chemistry type stuff. Chemistry, I think, was the worst grade I've ever gotten in my life when I was at Cal Poly. So not exactly my strong suit. Did take a lot of soil classes at Cal Poly though, so luckily not all of this is brand new. But the main things that I was talking about in terms of the chemical soil properties and wildfire is what happens with carbon, nitrogen, and phosphorus. So carbon, that actually kind of ties in well to what I was just talking about with soil color, where the book actually calls charcoal black carbon, kind of uses those terms interchangeably. And it's interesting how this works. What it was saying is that obviously you can have a net loss of carbon when a fire comes through because your bushes or trees can burn, your litter and duff can burn. That's made up of a lot of carbon, and then that can just turn into your smoke plume, then the wind carries that away, and it would be a loss of carbon from that environment. At the same time though, some of the carbon that's maybe trapped in some dead trees or maybe some live plants as well, some of that may be able to actually work its way back down into your soil and almost replenish the carbon within the soil, especially through that charcoal black carbon feature. And what I was reading is that it depends on the temperature of the fire. And I think this makes pretty good intuitive sense. If it's not as intense of a fire, then less of that carbon is going to be carried away, and more of it is going to be incomplete combustion, where you maybe end up with those little charcoal bits on your soil, and then that can actually mix down into your soils. But then if you have a very intense fire, then maybe 90% of the overall carbon exchange is just going to be lost. So hotter fire means more carbon lost from your environment, but I imagine it's not a complete loss. Maybe that means some other environment that's downwind picks up some carbon. So yeah, it's all just a balance of matter and forces within Earth. So yeah, matter can't be created or destroyed. So if one environment loses carbon, that by math you would have to, or physics, you'd have to say another environment must be picking up some carbon. Although some of that could be CO2 in the atmosphere, which could be a bad thing. But the basic takeaway there is that it depends on your soil temperatures what's going to happen to your carbon. And that seems to be a very similar case with the nitrogen and phosphorus as well, where it's saying if you have a very hot fire, then you can lose a lot of your nitrogen, especially if you're burning a lot of the litter and duff. But then, same with phosphorus as well, but then at the same time, some of that nitrogen and phosphorus can actually work its way down into the soils. And there was one very interesting thing that I read about. Let's see if I can get this right. It was saying that it was stemming off of that one where you have a very high intensity fire and you lose a lot of carbon. And it was saying that things like bacteria or fungi need that carbon to create new cells, and the bacteria or fungi are mostly made out of nitrogen. So what's interesting is if you lose a lot of carbon into, I don't know, the atmosphere, or it's just burned off, then that environment becomes carbon limited, and those bacteria or fungi now don't have the carbon that they need to create new cells, so then they die. And because they're mostly made up of nitrogen, that can actually increase the nitrogen in your soil, because the fungi or bacteria are dying because the carbon that they need was lost. So that's just an interesting little interaction. So I think before I talk too much about things that I don't totally understand, I'm maybe just going to wrap it up right there. And that actually is wrapping up the soil section of chapter 7, of how soil interacts with wildfire. I believe the next chapter is going to be talking about how water interacts with wildfire. So I think that should be fairly interesting as well. If you want to learn about that, you can stay tuned, and thanks for watching.